Okay, thank you very much. Thanks for that introduction. And I'd like to thank everybody who's there for, or in various places around the world for attending. I will jump right in. And I will start by saying a little bit about Kamusi as a project. Kamusi is the Swahili word for dictionary, and it started as a project for the Swahili language to build a dictionary. It's grown a bit. The goal is now to build a complete matrix of human expression across time and space, and to do this as a knowledge resource for people, as well as a data resource for computers, and as a basis for any-to-any language translation. We've been in service since 1994. It's now an NGO registered in the US and in Switzerland, and based in Lausanne, Switzerland at EPFL since 2013, as Michael said, at the Swiss EdTech Collider. Among other things, we've been part of the White House Big Data Initiative. This was under the Obama administration. Nothing happened under the Trump administration. We'll see what happened under the Biden administration. We're also working with ACALAN, the Intergovernmental African Language Board, for developing a platform for the languages of Africa. That has not started yet, but let's see where that goes. A bit about today's talk. Here's the roadmap. We'll start by talking about facts and fantasy.
Sorry to interrupt. If I might just jump in, Martin. Apologies. Are you sharing the PowerPoint presentation with us?
I am. Am I not getting the screen share? Did I not share my screen somehow?
No, I'm sorry. We can't see that. At least I can't. I'm not sure Olaf might call us.
I just need to press the share screen first.
Just click share screen and then select the PowerPoint on your desktop.
Sorry for that. A little technological stuff.
No problem. And then if you could just put it in slideshow mode at the bottom right-hand side. There you go.
I'm sorry about that.
Okay. I can see that perfectly now, so I think it should be okay for everybody else.
Very good, Martin. Thank you.
See the slides that I went. Here's the one with the EDL and EPFL. These were not actually important slides. Okay, so here we are. And let me get it. Okay, so this is the roadmap, and we'll look at the facts and fantasies, myths about AI and MT, and then talk about what we're doing at Kamusi. That's, I hope, the interesting part. So I'll probably go faster than I could through these other slides because they're filled with information, but hopefully you'll be able to go back and look at the slides afterwards to get some of the things that I skip over. One important thing is that over here, when we get to slide number 45, if there's going to be a little contest, there will be two slides, two images, one in purple, one in pink, and they'll be slightly different. And the first person who emails me at martin@kamusi.org with the explanation for what the difference is between the purple and the pink, I will mail a Swiss chocolate bar. And, okay, so what is AI? Well, we hear a lot about artificial intelligence, but a lot of that is a lot of hype. And people really are often talking about computers as artificial muscle, not really artificial brain, even when they're talking about AI. So artificial muscle is really using a computer to do brute force calculations, doing things a lot faster than we could, but with our instructions and really just as a convenience. For instance, calculating pi to a million decimal places. Whereas really artificial intelligence is where you're using the computers to analyze data, discover patterns, and follow new paths based on those patterns, things that we as humans couldn't figure out by ourselves, but we can put the computer to work at. And we're particularly talking about machine learning as part of this intelligence. Machines can learn if they achieve a desired outcome or if a human confirms that they have performed correctly the task that they've been set out to. For example, yes, that actually is a cat that the computer has identified as a cat. But you can see that there is a lot of hype about what might actually be artificial intelligence. Here they're talking about basically adjusting train schedules and speeds. That's more a computational muscle thing than it is a aspect of intelligence. So AI and COVID. So I named this talk back many months back when there were a lot of headlines about AI and COVID, and I was speculating that there might be more, but as it happens, AI has not actually cured COVID. Here are some of the headlines that have popped up about this magnificent technology. Here is one from way back in January, talking about AI battling coronavirus. And it actually has been used for quite some interesting things. And here, I want to be clear that I'm not disparaging the technology. I'm just saying that we want to be careful about what we understand about it. So it's been used to track articles written about coronavirus so that people can use natural language processing to hone in on the things that they're interested in. Researchers can find the relevant research for them. It's been used to track people who have coronavirus, see where they're going, and predict the path of the disease. It's been used for finding new drugs in terms of finding things that that might have better response to the receptors of the coronavirus and testing those rather than and eliminating some other candidates. And very interesting new use is that it can analyze people's coughs even over the telephone, and from their cough hear the patterns and determine whether they do or don't have coronavirus. Now, AI and the weather. This is actually a really wonderful use where AI can shine. If you think about all of the data that you have, we want to talk about analyzing data. Well, you know about temperature, you know about humidity, you know about pressure, you know about all sorts of other aspects of, factual aspects of what exists in various places. A computer can go through and look at those patterns, make predictions based on those patterns, and then they can actually test those predictions, right? You can see, was the weather that the machine was forecasting the same weather that actually occurred? If not, then the machine can adjust its algorithms, and if it did work, then it can say, okay, yes, okay, then now we've learned from that as well. On the other hand, there's online dating, where how is the machine going to figure out human chemistry? What does it know? Can it read your mind? Can it know what people will actually find attractive? And so what I did here, I'll go only very quickly through it. Somebody did end up telling me about a site called OkCupid, which does claim to use this sort of computer intelligence to find partners. And so I, myself, as a one-eyed middle-aged dad who doesn't speak the local language, I'm not actually prime beef for this service, but I did sign up in the interest of science to find out what is going on within OkCupid. And they ask you for your orientation, and then you start filling out answering all sorts of questions, or hundreds, even thousands of questions. At some point I ran out of interest in answering questions. Things like, do you like coffee? Do you have a child or children? Do you have tattoos? Are you carefree, better described as carefree or intense? And they have some little algorithm, some magic sauce that they like to do, where somehow, do you like coffee and do you have children, or get similar weights as questions, and they put that together, and then they come up with people who are recommended just for you. And they do this based on your number of agreements and disagreements. And without going into it too much, I encourage you to go back and look at the slides later. Basically what they're doing is they're discovering equal answers. They're not discovering patterns, right? They're not actually analyzing things like, okay, does this person tend to like brunettes who speak Spanish and went to college? No, they're just saying, okay, this person did go to college, and that person did go to college, and so there might be that might be some sort of compatibility. Basically, it is artificial muscle, right? They're separating out the wheat from the chaff for you, doing something that you couldn't do, which is go out and find people who have certain similarities to start with, and then, but they're not giving you a just, something that you can take to the bank or take to the altar. And why is this then similar to what's happening with language? Let's look at a case study. Here I looked at DeepL, which is one of the free online translation services. I recommend it. I use it a lot for translating letters into, business official letters into French for my life here in Switzerland. But you have to be very, very careful the way you use it. So in this case study, we're going to check, are we going to get the desired outcome that we want? The restrooms were out of order. They tell us, okay, les toilettes étaient hors d'usage. So hors d'usage is how they're getting out of order. And I looked at that and said, okay, yeah, that's pretty good. What about if I just do the singular restroom? And they now have done les toilettes étaient hors service. Okay, that works as well, and that's pretty cool. Nice they say les toilettes, even though I had the restroom in singular. So this is a definite win. Then I changed the word that's supposed to give context, so the machine is supposed to be able to figure out, right, that from collocated words, what you're actually talking about. Well, the files are also hors d'usage, not in usage. Where really, from this, you would probably say the files were misarranged somehow. You wanted something that means that, or you don't want to say that these files were on strike or not working. Then we go to change this to the motion was out of order. And actually they now got the right French side, which is probably because legal documents feature very highly in their training data. Inexplicably, they actually got the tense wrong, even though this is English to French, which is one of the most common language pairs and something that they obviously did right in the other cases, and they do right most of the time, but again, you have to be careful. So here we are, we've got our legal training documents, la motion est recevable, as I said, I don't speak French very well. So legal documents, okay, the lawyers were out of order. Actually, it says the lawyers were out of service. So again, it missed. So now we've got what we think are 3 out of 5 of these are misses. But with the lawyers being out of order, it gives us the option to choose what alternative we might want. And here I'm going to just choose déranger, which actually means deranged. The lawyers were deranged. The lawyers were a bit crazy. This, by the way, if you look at it, is what French speakers actually say would be the translation. But I've chosen that they were dérangés, and now DeepL is actually saying, I can save this as a rule. Now, I'm not sure if this is saying I can save this as a rule for locally, for me, or that this is now going to go to DeepL and they are going to use it as a rule to teach other people. I suspect they're going to use it as a rule for teaching other people. But why they would trust me as a consumer is a mystery to me. Okay, myths about AI and MT. I'll come back to some of those in a bit. But there are certain things, myths, that make us think that this is working in a lot better ways, or should than we think it is. So first are myths that we have the data. Second are myths that we have the methods, and then we have a lot of other biases and blind spots. we have the data. Okay, data are words that have been digitized in a way that can be used within computer processes. And when I'm talking about data, I'm talking about English, I'm talking about data for other high investment languages, and then other high population languages, and then the other 98% of languages. Let's look at English first. English has been, people have been working on language technology for English for 70 years. And I would propose that all English words have some sort of a digital existence, including party terms or multi-word expressions. These are the terms that have a special meaning when they're put together that can't be gotten from the sum of their parts. English has a lot of technology for natural language processing outside of translation, but just figuring out parts of speech, verb conjugations, all sorts of things like that. Even so, I would say that in a lot of cases, the relationship between the shape of a word, the way it's spelled, and the meaning behind it are not very well associated. I'll come back to that. And a lot of the English data is not interoperable. You can't go from one system to another. You couldn't go from Bing Translate to Merriam-Webster's, for instance, to know that you're talking about the same words. And there isn't a lot of reliable English to other languages in systematic sort of ways that can be used across platforms. Finally, English is only a small part of the global translation needs. Maximum of 15% of people in the world speak some sort of English, any sort of English. It's the focus of the translation industry, but maybe there are reasons that it ought to be, that focus ought to be expanded. Okay, the other high investment languages, we're talking mostly European languages, plus Arabic, Chinese, Korean, Japanese, basically where there's either tax money at work or corporate interests at work who want to fund that sort of research and investment. So a few dozen languages have a pretty good monolingual existence, some natural language processing, and these are often languages that have fairly extensive parallel corpora with English. These are corpuses that have sentence-to-sentence alignment between English and a professional translation to another language. But there are very few parallel corpora between other languages, non-English pairs, even among these few dozen high investment languages. And again, those systems are not interoperable, and you really can't go from Estonian to Catalan, for example, or even from one Estonian system to another Estonian system. So the other high population languages, now this starts to get where things start to fall apart. There are over 300, maybe 350 languages that are spoken by over 1 million people, including some languages that are spoken by over 100 million people, making them some of the largest languages in the world. But their digital presence is limited to things like this Swahili dictionary which is, yes, it's digitizing, meaning that you can look at it in an online form, but it's just a brick of text, and a computer wouldn't be able to make any sense out of what's going on with this stuff here. And that is very common for these 300 or so languages, if there's anything at all. The machine translation that exists for these languages, you can find it some in Bing, some in Google Translate, exists but is not usable. And some of them have monolingual corpora, but certainly not usable bilingual corpora with English, much less with any other languages. But I want to point out that these are not dying languages. And here you can see that this yellow box are people in Africa, for example, who've been born in the past quarter century. So 650 million people have been born. The population has doubled in 25 years. So these are people who are speaking very vibrant languages that just don't have technological services. The other 98% of languages, as Olaf Michael said, there are over 7,000 languages spoken in the world. I'm not going to argue that these are necessarily candidates for machine translation. You know, if you have a language like Omagua that's spoken by 10 people in the highlands of Peru, they probably are not out there angling for machine translation, but there are other technology things that uses of technology for preserving those languages and for preserving the heritage that are embedded in them, or providing certain services for people who speak those languages. And just the point, if we talk about universal translation, and we ignore 98% of the languages in the world, we're not talking about universal translation. Okay, do we have the methods? Well, the methods that are used, I'll talk about, are statistics, corpora, neural networks, zero-shot translation, and machine learning and other types of learning. Statistics. Statistics are still a part of MD services. It would be impossible to do a service like Google Translate or without statistics, because if people type in, for example, many people use those as a dictionary, and if they type in a single word, a neural network is not going to be able to guess what their intent of their meaning is, since neural networks work based on context. Statistics need parallel data, but basically they're somewhat sophisticated guesses. They're guessing that, okay, I see spring is related to primavera in 40% of parallel sentences with Spanish, whereas these other senses of spring only come up 10% of the time, and so therefore I, as an SMT, am going to pick close to 100% of the time the springtime sense of spring. You can find this if you go use the expression, the spring in her step, for your favorite language. You'll probably come up with the springtime sense. When we talk about corpora, as I said, we really don't have parallel corpora for most languages, but also we're talking about limited topics, because what is it that gets formally translated? What is it that gets officially translated and then is out there for use for language projects are going to be things like the European Union Parliament records. Daily speech, daily speech is very much outside of the scope of what a lot of corpuses can get in terms of actually having a decent translation. So that means that you don't get a lot of second-person constructions, like the sort of things that actually happen in correspondence. And as I said, Langui, DeepL is based a lot on these sort of official corpuses, and you can see them. You can see here, for the motion was out of order, all of the sources that Langui is using as the basis for DeepL. Okay, so here I said, if you, somebody can spot the difference between the lawyers were out of order and the lawyers were out of order, which Google gives two different translations of, both wrong, hors service, they're out of service, or they weren't in the rules, but not in a way that a French speaker would say. Then I will send you a bar of Swiss chocolate through the mail. Okay, what is it that's going on with neural networks? Well, first of all, I just want to emphasize, there is no brain. There are no neurons. This is just a metaphor. It's a good metaphor, it's a powerful metaphor, it's worked to market neural networks, and so you see lots and lots of news articles that really hype neural networks. That doesn't mean that they're actually thinking. They can run a lot of tests. They can do tests ABCD against EFGH, against WXYZ, and make all those comparisons and find hidden patterns. Yes, but there's no brain. So NMT, in association with statistics and various other techniques, does perform nicely in certain circumstances, and I recommend looking at this closely. The certain circumstances are when the language is at the upper tier of the languages that I tested on teachyoubackwards.com. The conversion is to or from English. Do not use it for other language pairs. The text is well structured and written using formal language in short sentences. Relates to formal topics and it doesn't matter, right? You're using it for casual purposes. If you're using it for healthcare, if you're using it for a legal document, if you're using it for business, be very, very, very careful. So as we saw, even when you have a lot of parallel data, there are a lot of misses. And so what happens with neural networks is that it relies in a large part on something I call MUSA, the make up stuff algorithm. If it doesn't know anything, it has the imperative to fill in the gaps. And so here, for example, it was on today's Facebook, somebody posted something in Somali, and Facebook translated it, and the only thing I can get is that must have something to do with fish because there's a picture of fish, and probably this congratulations to you probably is somewhat relevant. And if somebody, the first person who can send me a good English translation of that Somali, I will also send a bar of chocolate. martin@musi.org. Okay. Zero-shot translation is the idea that you can take language B, line it up with English, take language A, line it up with English, shake them, remove the English, and you've got translation. It doesn't work, but the reports are that it works. If you don't actually admit, if you don't actually read the articles on which they're based. Machine learning. There are two types of learning, right? There's machine learning and there's learning from users. So for machine learning works when you have a gold standard. And the problem with language is when you don't have a gold standard. You can have an infinite number of sentences, and those can be translated into in many different ways. So you can't, it's very difficult to train a computer, so you if you can get human validation of results, and I'll talk about how we might be able to do that later, you get garbage in, you get garbage out. And you risk locking in false information, even if something that's sometimes right, you risk saying that that's always right. Now, learning from users, on the other hand, is something that's possible. It's a different experiment I did with Google Translate over 4 years shows that their suggestion edit is not necessarily as effective as one might think it is. For reasons that you can read about at that link below. However, you can teach computers a lot about language if you want, and of course, Google and others who are developing self-driving cars actually do pay humans to identify road hazards in pictures, in millions of pictures. If they can pay people to identify road hazards so that their cars don't kill people, they could pay people to do certain linguistic things if they found that were something that were important to them, but they don't. Okay, other biases and blind spots. Let me put this on the table. Language technology is racist in that if you follow the money, if you look at corporate investment, if you look at government support, foundation grants, we really are talking about white languages mattering and a few of the very powerful Asian languages. In some cases, actually, this elite language bias is shared by leaders in places in Africa and India and other places. But when we're talking about language technology, we know what language technology has done in our lives, right? But that can't be done in the lives of people who don't have access, whose languages are not in that technology. And those languages are always excluded. The technology is inequitable, and that does matter. That does have effects in who has access to the engines of knowledge and prosperity. So here again is a graph. These are people in Nigeria, 100 million people who've been born in the past quarter century who are speaking Yoruba and Igbo and Hausa and have essentially no technology, no access to language technology, and can't say that English is going to do it for them because most of them are You know, there is some literacy in English by people who go to secondary school, but that's not the common opportunity for most people in Nigeria or throughout the rest of Africa or similar countries in similar conditions. Okay, a few other biases. We tend to trust that technology does what it claims. So if we look at a device, we think it's going to do what it says. So even if our GPS takes us down a cow path tomorrow, we will use it to get us somewhere else, try to get somewhere else with it, you know, the next day. If we search for an image, we trust that we're going to get an image of something we want. We don't actually recognize that what we're doing is, if we search for wild turkey, yes, the computer gets us so far. It's using that muscle and maybe a little intelligence to get us a wild turkey or a picture of Turkish wilderness or a bottle of alcohol called wild turkey. But we actually are making that the final decision, what it is that we intended. We're not actually leaving it to the computer. We think we're leaving it to the computer in many cases. And so that reflects in how we react to translation services, because we think, well, if we can put in, ask for wild turkey, we'll get a picture of a wild turkey. If we ask for wild turkey in Samoan, we'll get wild turkey in Samoan. And really, how is your Samoan? Can you test whether you're getting wild turkey in Samoan? Probably not. So we say, well, it isn't perfect, but we don't say what, we don't say whether, you know, is it close to perfect? Is it somewhere there, or is it really wrong? And in many cases, it's really wrong, as we were able to see with that Somali, but even in a lot of better done languages as well. But we willingly suspend our disbelief, and I think it's important to say that we root for the translation. We're rooting when we see that they got the right translation for one of the senses of out of order, the legal sense of out of order, then we say, okay, we got it right. Even though they didn't quite get the tense right, we're still happy to see that. So we don't mind, when they get the tense wrong, we don't mind the gaps, right? Because we fill in the hole in our heads. We say, oh, okay, that is in the present tense, but I meant it in the past tense, I can understand that. And then we have this confirmation bias that we know maybe we know some of how to translate from language A to language B, and so we figure the rest must just be beyond us. We don't know it, so, but seeing that what's there is correct, as far as we know, probably the rest must be okay. And there's a little magic wand that's going, so as we click along, things are changing on the side, and so we know that the computer is computing the best possible outcome and proof. So in the end, we end up often being gaslighted into thinking that it's correct just because it's there on the computer. And here I show you again these les toilettes étaient hors d'usage, which I was gaslighted into thinking was correct until my daughter, who is a native French speaker, came and said, no, that's not correct. That means that the janitor is washing the bathroom, so you can't use it. It doesn't mean that they're broken. Okay, so how do we fix things that are broken in MD? What is the path forward? Realistic facts and fantasies. I will talk today about what we're doing at Keynote, which are Smurfs and ducks, Cam4D. Those are things that are actually already done in place on our development servers, if not on the production server at the moment. And then Slover, which is something that's in the lab, and I have no idea when it's going to come out, but let's hope that that I can find the funding to somehow make it viable in the future. Technically, I think it can work. Okay, Smurfs and ducks. What are these? A Smurf is a spelling meaning unit reference. This is a number that gets assigned to an element we'll talk about in a minute. And this number can then be used so that Smurf, that piece of information, can be used across platforms interoperably, not just within the Keynote system, but will be on offer to other systems that want to get this, have access to that level of precision. Ducks are data unified concept knowledge sets, and again, I'll define those. And this is how you translate across languages. So Smurfs are within a language and ducks are across languages. So how does it work? Let's start with a word, something like light. Light is not one thing. Light is many things. For example, not dark, not serious, not full of calories, not heavy. Now, if I go to French, I'll use this in my example language. It's lumineux, allégé, not, it could be léger here, it could actually also be léger there. That's important. So, but if we now have French, Swahili, Finnish, Thai, for those different concepts, they're all going through the same English spelling of L-I-G-H-T. What we really want is we want these things clustered so that the things that mean the same stick together and don't get confused. But you end up with this much greater tangle, what I call linguistic linguini. What we want to do is we want to start with this thing that's light, not dark, not heavy, not serious, not fattening. Each of those is a Smurf, a spelling meaning unit reference. But there's the spelling is L-I-G-H-T, the meaning is not dark. The spelling is L-I-G-H-T, the meaning is not heavy. Each of those are separate little Smurfs. And each of their translations, their things that mean the same thing in a different language are also Smurfs in those languages. So the spelling lumineux here is a different Smurf than light, not dark, but it's also different from léger, and that léger is different from that léger, and that is different from allégé. We can add in Smurfs in different languages, and that is our duck, our data unified concept knowledge set. That's the duck for not dark, that's the duck for not heavy, that's the duck for not serious, that's the duck for not fattening. Our ducks are all in a row with all their little Smurfs. And as you can see with French, here, léger here, has several different meanings, without much luggage, low in alcohol, not heavy, sandy. Those are all different Smurfs as well, so they're not going to get confused. They each have their own reference number that can be used in various applications. And we can add in many more languages if we want. Each duck goes, and then you know that this language can, this concept in this term in this language is equivalent to this term in that language. Now, I don't want to say that they're exactly equivalent, but for the purposes of this talk, let's say that they're more or less equivalent. As of earlier this week, we had over 2 million Smurfs in 122 languages, and they were populating about 138,000 ducks in 48 languages that are really well interlinked. The others are language sets that are not necessarily integrated yet with the major language sets. So that brings us to CAM4D. CAM4D is our 4-dimensional database. Time being the 4th dimension, so there is a historical element. You can work your way backwards through the data to see where did words come from, how are words in German related to words in English based on their historical movement through Old English, Old German, that sort of thing. This is the graph database structure for the matrix that I was talking about. It is realistic. The final goal to get everything is an impossible aspiration, but I urge you to read the explanation of it at that length. And I'll discuss a little bit about the molecular lexicography design, although not too much for time reasons. Now, again, we started with light, and here we're talking about, we'll go to the Smurf for not dark. There's a little Smurf. As you can see, I've changed from a circle to a star because there are actually a lot of different aspects of this thing, light, not dark. It has a meaning, it has the shape, L-I-G-H-T, it has a sound, or it might have different sounds spoken in different places, has different relationships, has a historical existence, and might be spoken in one place but not in other locations. These can all be handled in a database, and they interlink in different ways. So these are, and each of these has smaller aspects. And if I had another hour, I would explain all of them, but I don't, so I won't. I'll just do one. You can see when I talk about shape, maybe I'm talking about something like the word drive. which has different what I call costumes. You might call them inflections. So the verb drive, drives, drove, driven, driving, driven, that those costumes apply equally to hitting a golf ball, operating a car, compelling somebody to do something, driving them to do that, right? Or herding animals, driving animals. From a machine perspective, you really only want to know once that it's drive, drove, driving, driven. You don't need to put each of those underneath each of these different Smurfs. And that's a sort of linkage that where different aspects of the knowledge about a term can really thrive in the graph system. For example, now if we know drives, we know that's present tense for a certain type of person, and then we can link that in a language model to another language and get their present tense for a second person or a third person second tense, third person present tense, and make those sorts of links that would otherwise have to be just calculated based on, that a neural network would have to calculate based on frequencies of how often it saw those particular forms without knowing necessarily anything about the tenses. And then these relationships, the herd of animals, and the relationship is going to the ducks, compelling someone is going to a different duck. And that all happens in this kind of molecular way where these things then interlink in these complicated connections that you can read about in COM4D. And I just want to give a shout out to people who've worked on developing this over the years. Greg McKean in South Africa started us off on this. Sina Mansour, who's from Iran, currently in Australia, followed up and got us quite some ways. And right now, we're working very closely with Jérôme Baton in Paris. He is actually the author of the book, Learning Neo4j. So he's really good at this, and he's been working for free for us for a year to try to get the system fully functional. And I have nothing but a great deal of thanks for all three of these guys for what they've done for the project thus far. Let me talk about where I want to go with this in this particular aspect with Slover to improve translation and maybe to use some artificial intelligence. I know I'm getting low on time, so I'm getting towards the end now. So, in Slover, we're not talking about this sort of instant translation where things are appearing as you type. Instead, we're talking about giving the user the opportunity to disambiguate this meaning that they want of a word like light on the source side. So they can, we will give them the options and they will choose. And if it's a party term, like drive up the wall, we will even be able to identify those and they will be able to get their meaning. So let's just look at how this works. Here's a sample sentence. She drove everyone in her class at school up the wall last night. First of all, we can use use the database through the costumes to find that drove goes back to drive. And I know in English, this is something that's already done. In other languages, it's not done. And so it should be done through data because it's not going to be able to be done through computational inference. But it's important that once we get this back to drive, we know that we can calculate downstream, okay, what are the party terms that begin with drive? There are some. Drive to distraction, drive up the wall. Oh yes, in this sentence we have drive up the wall. That means that these things have a meaning together that they don't, that should be given as an option. So yes, drive up the wall, annoy. Let the user select that this means annoy rather than driving a car up a wall. We can also see that we have multiple options for class, multiple options for school, and the user can choose schoolroom, can choose education, that it's an educational institution, rather than other options. And then again, with last night, they can choose not that last means previous, last means final, but that in this case it meant the night before. And then what happens is that we end up with a very well annotated, human annotated set on the source side of information that, oh yes, drove up the wall, goes to annoy, in last night in this context means night before, which we hopefully will then be able to put back into real learning, because now humans have taught us, not because, and these are people who we can trust because they probably speak the language on the source side. They know what they meant when they wanted a translation. They just don't know what the output was that they wanted. We can see that here, this is Bing, has a different approach. They take that same sentence, they get it absolutely wrong, but then they let you correct it, and then you can submit the correction, but we really have no idea why we should be trusting this person to submit that correction, what their grasp of language B is. And really, the question is why, why would anybody do that? Since they're asking for the translation, they're really not necessarily in a position to provide it. I do want to show again here, Sistran and DeepL both nicely got, and so here we're rooting for it. They got that everyone in this case, because it had deal with class in school, was actually tous les élèves, all the students. They both got that. Kudos to them. On the other hand, drive up the wall, they totally blew. So NMT sometimes yes, sometimes no. Okay, so then the user has marked all of their things, all of their senses, as many as they can. We use ducks to take the Smurf from the user's language and follow through and come up with suggested vocabulary on the other end that is very, very likely to be correct if we have the data already in the system. The machine learns from context-specific user selections, and we're able to then hopefully use this as the basis for AI. Now, I have to say that what happens on the other side, on the language B side, is really not our department. So I'm looking for partners who can help, who can take the sense data that we have and figure out really how to get the right syntax and work on language models the way to connect languages. Will users take time to use this software? Will they take time to disambiguate? I don't know. We do take time to choose our images. We take time to spell check. I think if we provide a better service, then people will, many people will use it. Of course, Google is on 1 billion devices around the world, and so people will go to Google Translate, and it'll take a long time before we're able to produce something and then get it out there for people to use that will be acknowledged as superior, but I think we just have to hopefully give it a try. How to pay for it, on the other hand, I have no idea. I'm open to suggestions. And if you have any thoughts, please contact me, and I recommend that you read those things. And I thank you for your attention. I look forward to your questions.
Thank you very much, Martin.